This short video demonstrates key capabilities in HyperCrash, a robust pre-processing environment specifically designed to automate the creation of high-fidelity models for crash analysis and safety evaluation. HyperCrash complements HyperMesh in the setup of a typical crash model. HyperMesh is the preferred tool for meshing and assembly. Once the geometry is properly meshed, HyperCrash may be invoked to complete the setup. In this brief overview, we will look sequentially to the different pull-down menus that are very indicative of the capabilities available in the modeling process to follow. The File pull-down menu allows us to import, merge, or convert Radios or LS-Dyna solver decks. For this example, we will import a Radios model. Once a model is loaded, the features under the Quality pull-down let you detect modeling imperfections due to penetration or intersection, disconnected parts, and errors that could prevent the solver from running. For example, a subsystem is selected in the tree. We can then use the Quality menu and the Check Intersections of Tree selection to list all of the detected intersections. Each intersection can be selected to see a more detailed view of the problem encountered. An automatic fix can be used to fix the intersections, or a manual fix can be employed to fix each intersection individually. Also in the Quality menu, the Connectivity of Tree selection will list all the parts in the selected subsystem in groups of connected components. You can also see the unconnected parts that need to be connected before running the simulation. Finally, the Model Checker will list any errors and warnings that could affect the simulation. The Connection pull-down lets you create advanced meshless welding connections such as spot weld with both 1D or solid representations, and other connections such as bolts, glue, and welding line. A key offering of Connection is the ability to create thousands of connections automatically accessing a typical connection file. The welds can be imported from an existing file or exported from this file. For this example, we will create a spot weld. After zooming into an area, the parts to be welded are selected. Then, elements are selected on one part to create the projection to the second part and create the spot weld. The Mesh Edit pull-down is commonly used for simple mesh modification tasks such as basic node and element creation and part manipulations. The Mass pull-down precisely calculates the mass of individual subsystems or entire models, allowing us to match a target value or to distribute masses to balance mass between the vehicle front and rear axis. All of this is done to increase the result's accuracy. First, let's look at the part details. This shows a list of all the components along with the calculated mass for each of the components. If necessary, mass can be added to the model if the mass of the component does not match the calculated value. The Match Target Mass option can then be used to update the mass values on the part. Notice the Added Mass column changes to add the mass to the component so that it matches the target value. The Mass pull-down also allows access to the Mass Balancing tool. In this tool, the front axle location and the rear axle location are selected. The total mass is then calculated for each location. The target mass can be edited if it does not match the experimental data. By selecting or deselecting, the mass is listed in HyperCrash to include or exclude the existing massed entities in the model from the ones available in HyperCrash will adjust the mass. The Model pull-down offers access to the Model Browser, the most effective tool to easily explore the model content, review, and edit its keywords. The Model Browser is designed to gradually replace the established tree, which is still a powerful tool for offering unique features such as part replacement. Also in the Model pull-down, other frequently used cards such as part material properties and control cards are available. Let's go through an example highlighting some of the key GUI capabilities. In the Model Browser, you can easily edit an entity, cross-reference, choose visibility options, and modify some of its parameters. The model menu also contains the capability to create or edit materials. By double-clicking, you can see the parameters within the selected material. You can also create a new material from a long list of supported Radios and Dyna materials. The final item for this example is selecting control cards for the model. A list of the Radios control cards appear. You can display the list of cards by active cards, all cards, alphabetical order, or by category. Under the Load Case menu, the user finds the majority of cards needed to complete the model setup, from contact interface to initial velocity, from rigid wall to airbag definition. Let's go through some examples to highlight key capabilities. The contact interface option is used to open the list of contact interfaces. You can double-click on an existing interface to see the properties, or right-click to create a new contact. The options available in this panel are common across the other selections. The Radios Tools pull-down offers access to other complementary features, such as transformation, local units, and other minor capabilities. Data History efficiently groups together panels that are able to create output requests for node elements, cross-sections, as well as accelerometers. The Safety pull-down is a powerful menu grouping among the most advanced HyperCrash features for occupant restraint system definition. The Dummy Positioner allows you to import and articulate multiple dummies. All the latest Humanetics dummies are supported, and so are FE dummies created by other suppliers in both Radios and LS-Dyna formats. Seatbelt routing for 1D and 2D belt generation, and finally, Seat Deformer to shape the geometry of a seat cushion and fit the profile of a dummy. The Process and Option pull-down completes this overview with its additional functionalities, among which the Result Mapper is the most distinguished for the ability to import and project metal-forming results to a crash-type mesh.